All right, welcome everyone to today's talk. Today's talk is Intro to Bug Bounties and Recon Basics. So my name is Ali, and today I'll be talking about what bug bounties are, how they work, and also the first step in getting started in a new program, which is Recon. Flip the slides on the. Oops. I flipped to. Okay. So, table of contents. So here are the topics we're going to be going through today. So first is going to be a bug bounty primer. So just everything. So what is a bug bounty? Why do they even exist? And how they work. Then I'm going to go into subdomain enumeration, which can be very useful when you're starting out because you can find a lot of web apps that belong to your target. And then we're going to go into directory and file enumeration, which can help you find like unreferenced files or stuff that may be outdated but still online for some reason, which can also be useful. And then in the end, I'll give you some further learning resources that will help you move on past the content of this talk and where to find more ways to get better. So part one, bug bounties, the overview. So what's a bug bounty? So basically how it works is companies have this program where they award monetary rewards to hackers in exchange for successfully discovering and reporting security vulnerabilities. And then if you're just introduced to this out of the blue, it sounds a little bit counterintuitive, like why would I be paying hackers to hack into my system? Well, this gives hackers the incentive to do responsible disclosure, which is to go to the vendor and work with them in making their system more secure. And it also it gives the company a very useful tool to harden their own security posture. And also, like a little bit of a side note. So over the years, there's this black 0-day market that has developed in the background. And basically, what happens is in many countries, hackers do research and then they sell these vulnerabilities to 0-day brokers. And those brokers in turn go and sell to nation state governments or criminals or basically whoever will pay the most. So moving on, here's a small excerpt on from the Lex Friedman's podcast speaking about why do bug bounties exist. So let me play that real quick. And then, so speaking in this video is Nicole Perlroth, who is a cybersecurity journalist who writes for the New York Times. She wrote a book about the emergence of the 0-day market, and she explains how businesses in the early days of the internet actually played a role in the development of this market. So let's skip ahead. Yeah, let me fix the audio real quick. Does everybody know how the audio works in here? I switched the output, but it's still not showing up. Yeah, so here I have the sound.
You're plugged into HDMI, so you're gonna want to make sure your output device is connected.
Yeah.
What other options do you have for the output device? Do you have battery control? Probably not.
Yeah. All right. Well,
You can turn on closed captions and do it dramatically.
Yes.
It's okay.
You can also play on your.
All right. Well, I can just tell you what she says. So, huh? Yeah. Yeah, it's okay. So basically, what she says here is that after research and after going to,
And what I found was there was long recorded history. It started out in the 80s and 90s. Hackers were finding holes inside the software for curiosity. It's really about poverty. And some of them would go to a company like Microsoft, which done major difference than for Oracle. And she'd say, hey, I just found this here in software, use it, breaking an asset. And the general response I was told was that thank you so much for pointing out the flaw in our software that fixed it as possible. It was don't ever program our software ever again, so we'll stick our general purpose. And
So generally what happened is that they alienated all the hackers who acted in good faith and who tried to do the responsible thing. And then they started to basically get paid for their time by selling these vulnerabilities and exploits to people who have basically no morals. And that to that being the new norm, right? So bug bounties have emerged to fix this and give more incentive into acting more responsibly. Yeah, so since this is a beginner talk, I'm going to be talking about the skills needed for web bug bounty programs. So bug bounty programs are just vulnerability disclosure programs. So it can be any technology, it can be mobile apps, it can be just cracking binaries, it can be just basically hacking any technology that the client company provides. But in this case, just to keep it simple, I'm just covering web. And I think these are probably the best starting point. So to be able to do a web bug bounty, you need to have an understanding of HTTP. And this basically lets you understand how the data moves around in the web app. Also, you have to know, well, you don't have to know, but it's better to know Burp Suite because Burp Suite gives you a lot of control into the outgoing packets and lets you manipulate like the parameters in a more controlled manner. It also gives you more features like the burp repeater, where you can have one request that you can probably send over and over and over while testing different payloads. And then finally, you have to know at least one web vulnerability. So actually, even if you know more than one, if you're starting out in web bug bounty, a good tip is to pick one vulnerability that you feel good about and then just spamming that everywhere. So what's going to happen is that you're going to get good at it, and then eventually you're going to start popping that vulnerability in higher profile web apps. And yeah, and then moving on. So here's what I recommend for people to start with. So UT has a bug bounty program, and I think it's perfect for people trying to start out. And so the reason this is good for beginners is because you don't have a lot of competition. It's only open for UT affiliated people, so only other students and also staff. So then why is this worth your time, basically? So most importantly, you're making UT a safer place. So that should be your first concern. And then moving on, ISO is very friendly with students. So when you do a lot of bug bounties, a lot of the people who are triaging the vulnerabilities are making sure that your report is valid and this actually exists. They're basically trying to rip you off. So they're gonna say like, oh, somebody else reported this before you and nobody actually did. Or maybe they'll tell you this isn't like this isn't dangerous enough for us to give you a payout. They're gonna try to play tricks like that. ISO doesn't do that, especially when they're a student. When you're a student, they help you out and they give you tips. Like if you submit something, they'll tell you like maybe if you can chain it with this type of vulnerability, it would have a high enough impact for a payload. And then also UT has a very large attack surface. So I'm going to be going on later about passive enumeration techniques. And if you do this on UT, you're going to find so many different web apps and probably a lot of vulnerabilities. And that's actually my next point. Well, not the next point. So UT has ISO, also has amazing response time. So there are also a lot of student I don't know well, good response time for me like is 2 weeks. That's when fair enough.
Me and the Discord may get something, a better response time.
All right, fair enough. That guy's trying to give you a shout out. But anyway, they have a decent response time. Especially if you ping Daniel and so on.
Anyone who doesn't know, can you explain what ISO is?
Yeah, so ISO is the Information Security Office, right, at UT. So basically they handle a lot of the security operations, including the bug bounty program, and they also make a lot of security solutions for businesses, right, like Stash and things like that.
Mostly for the educational sector. Other Basically, ISO is built on tools for UT, and they also let other groups use it.
Well, they're a very cool group of people as well. And moving on, UT has a lot of bugs. So if you pick any one web vulnerability and then you do the things like the enumeration steps that I'm going to tell you in a second, and then you start firing these off at a lot of the targets, I guarantee you will find something. Like I literally found I think I can say this. I found one of the bugs while waiting for a class to start on my phone. So yeah, if you give it a good swing, you'll find some. And yeah, and so I want to speak for a little bit about the importance of recon. So usually when you find like an intro talk like this one, people will go straight into exploitation, like, hey, let me show you some XSS or some SQL injection or some stuff like that. But I wanted to cover recon today because it's very heavily neglected, I feel like, and overlooked, because it can be seen as maybe not as technical as other exploits, and also it might not be as exciting. Garrett?
What is recon?
So recon is reconnaissance. It's the process of information gathering. And so these tips are from this book, The Basics of Hacking and Pen Testing. And I really recommend this book if you're getting started in security. I actually have a copy with me today if somebody wants to borrow it. I think I have it. But this is where I started. It's a really good book. It's rather than having like a deep intro into any one part of hacking, this is like a shallow intro that encompasses the whole workflow. So really good book, recommend. And so why is recon important? So your chances of success are proportional to the time spent on recon. So if you spend a lot of time mapping out your target, you will end up with more information. You can make more conscious decisions about where to direct your efforts. And also if you're doing passive recon, so passive recon is when you're gathering information from public sources without directly interacting with the target. And that means that it's not limited by scope. So when you're doing a bug bounty, usually they tell you can only test that type of assets. So you can't interact with anything else that they own. But when you're doing recon, everything is fair game. And then it broadens your attack surface. So there are just more things to try. And one thing that I want to really emphasize is that you should have a well thought out methodology. So I'm going to introduce you to some tools. I encourage you afterwards to go and look for more. And then think about which, like in every context that you're in, think about which will give you the most return. And take some time to really think about that and come up with a solid methodology to follow. And yeah, and I wanted to introduce some concepts. So recon has two types. There's active recon and passive recon. So active recon is stuff like maybe brute forcing files and seeing what comes up. You're heavily interacting with the target. You're sending a lot of requests. This is very noisy, and most bug bounty programs really don't like this because it puts a load on their like public facing production environment. And if their website is not very good, it might take it down. So this is not really something you want to start with. And it's not something you want to do unless explicitly told that it's okay. But if you're doing passive recon, then you're going to be fine most of the time. So this is where you should start every time. So just in short, like active recon, bad, passive recon, good. So just keep that in mind.
So can I add something like this?
Yeah, go ahead.
Yeah, so anyone interested in the YouTube bug bounty, keep in mind that the USO's automated standard is pretty So. Passive recon is fine. You know, it's-
Twitter will generate a lot of
if it's a bunch of requests that are automatically generated, it's.
Yeah.
If you're using intercept or something, that's.
yeah, so be careful with active recon. Passive recon is always going to be okay, so you should start there. Also, if something is unreferenced, like it's still up, but they just took out all the external links to it. You will not be able to find it using active recon, but passive recon might reveal it to you. So there's merit to using passive recon even when you can do active. But yeah, before I just to close off this section, I wanted to leave you with a quote of Abraham Lincoln. He said, "If I had 6 hours to chop down a tree, I'd spend the first 4 sharpening my axe. So do your recon, prepare properly, and it will pay off in the end." Okay, now to the more technical stuff. So subdomain enumeration. So this is the process of finding more websites within your scope, basically. So it's so subdomain enumeration, what it actually is a reconnaissance phase, which helps you broaden your attack surface by finding hidden applications, and sometimes the subdomains are even forgotten. So this is a good way to find those as well. So I'm going to be going through 3 tools for this section. The very first one is sublister. So sublister is kind of like the classic example of a passive domain enumeration tool. And it's kind of old. So it's written in Python, and the last commit to its project on GitHub is actually 3 years ago. So it's a little bit dated. It still works though. A lot of people rely on this. And basically how it works. So I'm not going to be going through like the switches to the command. If you download the command or if you have a running instance of Kali, you can just do -h and it will show you what the options are. But I'm going to be going a little bit into how it works so that you can understand what it's actually doing. So it uses search directives for popular search engines, which are like filters. And that's how it enumerates subdomains. And then it uses regex to extract a lot of those results. So a lot of search engines don't like automation, so they don't have a clean API. So you would have to just render the HTML page and then look for patterns and then extract the information that way. And then the other sources that Sublister goes through is ThreatCrowd, VirusTotal, and OTX. So what these are like basically like open, they're a crowdsourced platform of a lot of like how should I say this? Like maybe viruses, or it's basically like a neighborhood watch. So they will have a lot of links that you can mine as well. So if you have like, does anybody have a Ring? You know, like the Ring app, how you look and you see like posts from your neighbors, and then it's something like that. So this is also a good source for information. Did you have a question? Yeah. Cool. All right, moving on. Subfinder. So Subfinder is like the younger brother of Sublister. This is the modern version. It's written in Go and it's optimized for speed. So if you want to do the same exact thing, this is what you would go for. This is a larger project. Sublister had like 20 contributors on GitHub. This one has 60. And it also provides a library for you to use in your own automation scripts. So as you do more bug bounties, you're probably gonna fall into a workflow and know what you do like at the start of each project. So what most people end up doing is automating that process. So it gives you a really nice way to do that. And then finally, we have DNS Dumpster. So DNS Dumpster is a source that is actually used by both Subfinder and Sublister, but I wanted to cover it here just to go into how it works in the background. So what it does is that it does reverse DNS lookups of the target's IP space. Does anybody want an explanation, like a quick explanation of DNS, how it works? Yeah, anyone? Okay, yeah. Thank you. Yeah, have a market. Does anybody have a market? There's one here. But yeah, basically, DNS works is the way to access servers you can. But these are just numbers which are hard for people to remember. So when you use domain names, which is like that, something like that's just the regular URL that you see. So basically, we have DNS servers that have like a table that have like mappings of domain name, like let's say google.com to some IP. And then when you enter a URL into your browser, it will send a query to one of those servers. And then it will say, okay, I'm on google.com, where is that located? And then it gives it the IP address. Right? So usually what the data request for is an IPv4, and that's stored in what's called a J record. So there are different types of records for the server. And then when you're doing a reverse DNS lookup, you basically have the IP, and then you do the lookup package. This is a different kind of record. It's called a pointer. So it has the IP. If you look up by, this is probably too small. And then it maps to domain. So why is this useful? Why am I doing that? And probably I'm starting out with the URL. So what happens is out of companies, what they do, they use the same server for multiple subdomains. And then when you do the reverse DNS lookup, you're specifying what the server is, and then you're requesting all the domain names that belong on that server. So if you start with one domain name for your target, you can end up finding it. Any questions?
First DNS are a single IP, you get multiple domains.
That's how this works.
Where
It goes so every so when UT runs the like a specific cyberspace, they're responsible for having the DNS mappings for the domains that they own. So what happens is that the request goes to a root server, which is run by an application non-profit organization, which runs like the backbone of the internet, and then it forwards it from less specific to more specific. So it will send it to UT. So it's, let's say, cs.utexas.edu. So that edu is called that's the root level domain, right? So top level domain, sorry. It's the top level domain. So this will go to the root DNS server, right? And then the root DNS server is going to look at the next one. That's the second level domain. And it's going to see Texas. So it's going to be like, so the root is going to recognize Texas, and then it's going to send the IP for the next one. So then your DNS server will send a query to Texas. Okay. Question was, it works. I think it works the same way. Also, I think if you just
So what happens is that there are domain names that the IP addresses are bound to. I think right before it'll like 8.8.8.8. It's just a DNS query to 8.8.8.8 in dash ADER dot.
yeah, I'm not really sure how it works backwards, but that would make sense.
So there's like an official scheme to map IP addresses to an actual domain names. And then the actual record type is a PCR record. It's also just a quick thing. Edu isn't actually stored on the root servers. Edu is stored on the TLD servers. The root servers is actually if you look at like a full requalified domain name, there's sometimes like an implicit dot and dirty A. So there's a big set of root servers, and they'll point to TLD servers, and that's where .edu.com, .gov, .net, all of those will be stored on.
Let me this right up. All right, so reverse DNS is the main mechanic the DNS dumpster uses to work. They also so they try to find other data in DNS records. So they're so DNS servers can also hold another type of record called a text record, and that holds like just information that whoever the administrator of the server is can put in these. So that can reveal even more assets for you to go scan and go look at. And also DNS dumpster does some banner grabbing. So banner grabbing is actually active. So I'm not sure how they're doing it, but if they're interacting with the target, then they're doing it for you. So as far as you're concerned, this is still passive. So I wouldn't worry about it. And the banner would tell you what kind of service is running on this host. So if you actually run this on the CS department, you'll see a lot of SSH hosts. These are the lab machines probably. But you also, if you're doing the bug bounty, you're just looking at the HTTP ones. Yeah, so that's DNS dumpster. And moving on, we're going to directory and file enumeration. Yeah. They both use it. So Sublister and Subfinder, they're just an automation. So all of the stuff that they do, you can easily do by hand, but they just make it a lot quicker. And so in hacking, what separates the people who are really good from the mediocre ones is the ability to code. So I would really recommend taking some time and making your own tool that does the same thing. So maybe it won't be as optimized, maybe you wouldn't use it as your main tool, but I think the exercise can be very valuable. So it's a good thing to do. So
About the Subfinder, Sublister, do we only do the DNS lookups or do they use any other methods for?
okay, so Subfinder and Sublister don't really do anything special. They have a bunch of APIs for the crowdsourced like the crowdsourced platforms I told you about, like OTX and VirusTotal and yeah, so they do that. Also, they fetch stuff from DNS dumpster, which also I think has an API. So yeah, all they're doing is just searching and scraping. They're not doing any sort of DNS. But yeah, so okay, so now to directory and file enumeration. So you found a subdomain that you want to test. That's basically a separate website. So a good thing to do now is to find out how many pages are on that website and what they look like, or what they're just find out where they are. Right. So the Wayback Machine is a good way to find that kind of information. And it has a very nice API that you can use. You can also have regex to do pattern matching. So you can find like more pages that fit a certain subdomain or domain that you're looking at. And basically, this is an initiative by the Internet Archive to document the development of the internet. So they have snapshots of different websites across time. This is the UT website in 2000. I think it's 2000, but yeah. So it's pretty old, looks pretty old, but it's cool to check out these websites, how they used to look like. So it's fun to mess around with. And this can also be used for subdomain enumeration as well, if you really want to. And yeah. And then the next tool is Common Crawl. So Common Crawl look like it works sort of like the Wayback Machine, except this is more current data, and it doesn't save the snapshot of the website. So what this does is that it has web crawlers, and web crawlers are programs that go, they start at a web page and then they click all the links, right? And they basically visit all those websites and index it. So basically what Common Crawl keeps track of is the crawl data. And then they use a specific file type to store that, which is called like WARC, and I think it stands for Web Archive. And they're sponsored by Amazon, which basically means that they get free hosting. They don't really actually get a sponsorship, but I mean it's still kind of nice. And then they provide a Python API. So they provide it also in a lot of different languages. So if you'd like to write a program to get some practice that uses this, you have a very convenient way to do it. And then the last tool, and this is what I use, basically every time I look at a new program, this is what I go to. This is a tool called GAL, and it stands for Get All URLs. And this automates like it automates the Wayback Machine and looking at Common Crawl and also a lot of other sources. So it's a pretty small project and it's written by a guy. This is his handle at hacker underscore at Twitter. I'd recommend following him because when he finds like interesting stuff, he will redact information, but he will give you like his entire methodology. So it's a really good resource to learn from if you're trying to get good at this. And yeah, so what this does, why it's really nice is because like it has like 4 different sources, I think 5 different sources, and you don't have to learn the API for all of them. You can just use the switches, you make just a generic query, and it translates your requirements into those APIs, scrapes it, and then outputs everything nicely into a file that you can then sort or like filter and work with. And yeah, and that's it for directory enumeration. So now we go on to further learning resources. So how do I get good? How do I take this and go to the next level? So here are good sources for where you can go from here. These are sources that I started with, and they're still the ones that I use now. First, Twitter. There's a lot of high-profile bug hunters on Twitter that share a lot of good information. They also recommend a lot of good tools, so you can definitely learn a lot from there. There's the gentleman, Hacker, and then NahamSec and Christy Vlad. So I talked about HackerOne, I think. So HackerOne is where UT does their bug bounty. There's another platform called BugCrowd, and I think Christy Vlad is a spokesperson for them. And he does he has a lot of bug bounty training material out there. And then also you can go to Udemy. So when you're actually trying to learn about vulnerabilities, there's a lot of courses on Udemy that are targeted towards web hacking in general, and some of them are specifically for bug bounty. So those are also worth checking out. Also, Udemy is entirely video based. So if you get tired of reading, you can just go there and it's all videos and they have a lot of demonstrations. And then this is really important for bug bounties, the HackerOne disclosed reports, because these are actual vulnerabilities that have been found in live production, like production level instances of very high profile programs. So you can go and see how somebody found like a buffer overflow in PlayStation and did like basically got like admin access and he can now get cracked games on the console. I think that guy got paid. You can also see the payouts. So that guy got paid $10,000. Some guy found cross-site scripting on which I can't say it. I'm not gonna speak about UT. Some guy found cross-site scripting in Reddit, and cross-site scripting is pretty basic, and he got paid $5,000. So you can sort of get to see what the ranges are for payouts. You can see this on the main page for each of these programs, but this is good for sort of seeing the pattern and seeing what things you should be looking for. And then finally, Hack the Box. Hack the Box is the #1 gamified hacking platform in the world. You can go there. They have a lot of virtual machines, and all of them they're intentionally vulnerable for you to test, and they have a wide range of vulnerabilities for you to play around with. And also, they have a lot of good write-ups. So whenever you get stuck, there's something to learn from, and then you can see maybe where you went wrong and what to do better the next time. And finally, happy hacking. Thank you all for being here, and this is it for Bug Bounty.